Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining our episode number 27 of Going Meta, a series on graph semantics and knowledge. Very welcome to everybody who's joined freshly, newly to this series. Everybody who has been around for a while. Thank you for coming back. Thank you for giving us the reasons to go on and to continue with this lovely series here on YouTube or LinkedIn or X or wherever you're watching this right now. Or if you're watching it on demand, then welcome to you as well for later in the time. And specifically, today we have, as usual, a great person with me, and that great person is Jesus. Hi, Jesus. How is it going?
Hey. Hi, Alex. Yeah, it's going great. Yeah, really excited to be here again. It looks like, it gets shorter and shorter between episodes. I don't know, it feels like we were here yesterday, but it's really excited. And I think we're having a very interesting topic today. So yeah. Looking forward to it.
It does look like that, and even though March has not been a shorter month, maybe even this year we don't even have an excuse. I mean, February was a long one this year, so we don't have anything to say about that. It's
just a busy time, maybe a lot going on, and
yeah. Especially, I mean, I guess for some it has been a long weekend. At least here in Europe, it had been a nice long weekend with a couple of days off. So that was nice. So maybe that is also why it feels like sometimes things are moving quickly, and we're into April already. I think this is probably as early as we can be in the month as well. So maybe this is another reason we are doing these on the first Tuesday of the month. So I mean, being today the second, it couldn't be almost any earlier. I mean, the first could have been a Tuesday, and obviously that's that. But we are very very regular, I would say, with this date. We try to keep it as much as possible. So if you are looking forward to the next episode already, then the next one will be the first Tuesday of the month, probably again. We'll confirm it soon after. But yeah, I'm looking forward to today. It should be a fun one. It should be an interesting one. We are talking about building reflection agents with LangGraph. So LangGraph is, without taking anything away from the actual thing you're going to say, because I'm pretty sure you will explain what a reflection agent is. But LangGraph is a part of the LangChain library that is used pretty frequently nowadays in the GenAI ecosystem. Lots of things are orchestrated through LangChain, specifically with the graph rag things we talked about in a couple of these episodes on this session, but also in the wider GenAI world. I think you probably stumbled across this, and LangGraph is how would you say, is a sub part of or a sub implementation.
Yeah, LangChain define it as an API that's it's a library kind of that's built on top of LangChain, and that helps creating applications, agents based on LLMs. And what's interesting about it is that you actually build a graph, like a flow chart of what how your application reasons. And I think that's a very interesting thing. I'll kind of spend a couple of slides explaining how I got to this idea and why. And where we're going to take it from here, because I think that brings a bit of context. But yeah, that's it. I mean, it's one of the most, I think it's by far the most popular kind of orchestration library in Python for building LLM applications, and it's amazing the work that they're doing. And for me, it's kind of these sessions are an excuse to to dive deeper in some of these technologies that are moving so fast and to learn. So I hope I'm going to be today sharing what I've learned over the last few days, few weeks. And LangGraph is really powerful and really interesting. So I think it's going to be an interesting one.
I think that's really good. I'm also writing the Neo4j newsletter that comes out on a weekly weekly schedule. And this week, I'm featuring an interesting website, and I'd like to share it with you today. I think it's a good fit. We have a Neo4j Labs page on the GenAI ecosystem, which collects all the interesting bits and all the interesting libraries, demos, examples, training courses, interesting blog posts, all this stuff. in around the GenAI world, and lots of LangChain implementations as well. And I put the link in chat, and I'll put it in the video description on YouTube as well. So if you are in this space, interested in it, this is a great resource with many links that gets updated. I would almost daily, but not really, but very frequently. When something new comes out, then we put it up there. So it's a good resource to check back on. And yeah, I think with that, I'm happy to dive in. Let's get let's put this on. Perfect.
As usual, well, let's use a couple of slides to give some context and to set the scene for the more hands-on part that we'll use in the second part. The idea is we're going to get to building a reflection agent, and we'll explain what that means, and we're going to use LangGraph. But like I was saying before, I mean, the initial idea was slightly different, and it started with this deck that I suppose we'll be sharing. I mean, you can probably copy the link down there, but this deck from the LangChain team, from Lance Martin, where he was kind of discussing or reflecting on starting from this tweet where he was kind of asked whether RAG was dead when the context windows were growing and it was practically unlimited, the amount of information that we can pass to LLMs. And spoiler, I mean, the conclusion is it's very much not dead. It's more alive than ever. And what's interesting, and I totally recommend you go to watch this deck. And there's a YouTube video that I think it's linked in some of the pages, or several ones, where he explores some of the ways in which RAG is actually evolving, and it's becoming a very rich kind of approach to integrating LLMs and an external grounding databases, or data knowledge bases, if you want. And so my initial idea was, because if you think of it, Alex, what we've done always, we show in a pretty linear way how if you do RAG based on a knowledge graph, it improves significantly by providing context, the accuracy and the quality of the data that you would retrieve if you were looking at, for example, just a vector database. But the reality is that RAG, the retrieval step, is becoming way richer. It's not necessarily a linear process where you go retrieve and whatever you get, filter or pre-filter, post-filter, you pass it on to the LLM. And what Lance was describing in this deck is that there are very rich patterns to do some reasoning, like things like, for example, I evaluate the quality of what I've retrieved. Is that information that I have retrieved from my knowledge graph, from my vector database, whatever my grounding database is it relevant to answer the question that I'm trying, or to fulfill the task that I'm trying to the LLM to fulfill, or is it not? And depending on that, I might decide to do several things. Like, and he talks about, maybe you want to go and search the web, for example, or use any other tool, or reiterate or refine or come back and do multiple iterations of retrieval. Anyway, I was thinking that there's something really interesting there, and I wanted to explore that. But I thought I put this idea on hold when I again Dan Koski created trouble and posted again. I follow him, and he's a great source of super relevant and up-to-date information on everything graphs and but also on GenAI, of course. And he talked about this idea of agents. I mean, he basically referred to this presentation by Andrew Ng. And at the same event, there was actually a presentation by Harrison Chase from LangChain, and they were both talking about agents. And the idea of agents is how not only the retrieval part, but how the interaction with LLMs is becoming richer, right? It's not like, again, a linear thing, which we might have shown in simpler examples, and how it becomes a lot more interesting. And in particular, Andrew and again, these two, I think the two links are in the comments. So if you want to share them, Alex, or we can do it after. He talked about how we can build. He refers to that as agentic behaviors or agentic patterns. So does our application behave as an agent, or just as a non-agentic workload? Does it just do a thing, starts and ends, the example that you see on the left? Or does it do something more like iterative, something, because that's the way we actually work. And that's that's what made me change my mind, and because that connected very well with episode -2, that was 27, it was
5.
25, right? Where we did like this model generation, automating the model generation, right? We had a data set, a flattened or a denormalized data set, and we tried the LLM to generate a graph model, and then we moved the data from this tabular format into Neo4j, and it was fully automated. But we took this approach, like, okay, we get the metadata of the data set, we produce a model, and boom, we generate the cipher inputs, and the data is migrated. And if you think of it, it's never like that. I mean, in a real world scenario, we don't model and that's it. I mean, you typically come up with a first model, you share it with someone else, so with your co-worker, with your colleagues, and you iterate, right? So if you're working as a team, you iterate on that until you come up with a version of it that you're comfortable with, or that you think is right. And that's exactly what he describes as one of the patterns, because he describes a number of them. But that's more realistic, and he was talking about the amazing results that can be achieved by following these approach, right? So I thought that was probably something worth exploring, and it's somehow connected to the previous, which we'll just park for now, and we'll talk more, which is this idea of the kind of apply the same idea of reflection on the retrieval step on a RAG application. So I retrieve, but then I do some reasoning in terms of evaluating how good it is, and whether that's that requires additional iterations. So we'll, like I said, that's something that we'll do in future episodes. But this was kind of a sort of a low hanging fruit, and I thought I'd dive into it. And what I of course found,
it makes it. Oh yeah, okay, yeah. I haven't seen your slides, so believe me if I say this. I just wanted to say this. This now makes interacting with an LLM even more human-like, because you do something, you think about it, and you change a little bit of what you do, and then you reiterate on this. And this is your slide here, right there. So
absolutely, yeah. Well, and this is the version from you have the URL there from the LangChain, or what they define reflection agents, but it's in the presentation that I was showing before. I don't know if it's readable here, but he kind of describes the same idea, Andrew Yang. So the idea of reflection is you ask the LLM to generate some code, and this is this person to the left, but then you have another kind of actor in your application that acts as a reviewer, right? So and it might be the same LLM. So it's the same LLM that you use to generate the code in the first place. But if you ask it to act as a critic, as a reviewer, to highlight points of improvement or issues with whatever has been generated, you kind of create this cycle, this iterative process that kind of simulates, like you were saying, the human process of building solutions. And that's exactly the way the LangChain team describe it. And here the basic example, which is the one that I'll be implementing today, is you have some user requests. In our case, it's going to be generate a model out of this data set, and we will do an initial generation, and then we will reflect on it. And we will reflect it. I mean, the LLM will reflect on its creation, and it will produce some reflections that will kind of maybe trigger the generation of a new version of the initial model, and so on and so forth. And you can repeat that process many times until you consider that the process, I mean, the quality is the one that's expected, or the requirements are met, whatever the termination condition is, and then you return the result. But it's not like a linear process anymore. It's kind of a more richer, more complex, and in this case, an iterative and cyclic exercise. So that's the idea of a reflective agent. It reflects on its own production, and you use that reflection to kind of iterate and make it eventually, obviously, better. Right. So that's the idea. So does it make sense? Does it align with your thinking as well?
Yeah, that makes a perfect sense, and I think that's a really interesting journey, so to speak, where we came from, right? I mean, we if you remember going back a couple of months when everything was about ChatGPT and it's going to be the new savior and of everything, and you just put in something there, and then your answers on any kind are created back to you in almost magically. Then people realize, oh, actually, you need context. You need there's hallucination involved. There's problems there if you don't ground your LLM. If you do that's like first step. And now here, next step almost is like, okay, yeah, but sure, you need all the context, but still you kind of need to iterate a little bit about it. You need to think about what the first shot is usually not the best. Rarely. I mean, if you're a genius, maybe it is, but if you're not in a first draft or something, is good, okay, but then you iterate on it, you do some thinking, you tweaks here and there, and then you improve over it, and then you at some point you say, oh yeah, that's not good enough. Let's ship it, basically.
Absolutely. Yeah, totally. And that's exactly what well, one of the things that LangChain in general, but LangGraph helps us with. And again, there's a couple of links there that I invite you to take a look at. And these are the tools that we're going to be using in today's session. And again, the problem that we're going to be experimenting with is the one from episode 25. If you remember it, what we did is we took a data set from Kaggle, I think we used. And that was particularly convenient because Kaggle, as we're going to see, if you probably remember, it offers kind of an endpoint where you can just look at the metadata of the data set. So which are the fields, which are the data types, is there a description? So you can very easily query that. And that's all we need for the generation. If you remember, what we did is we get the metadata out of any public data set. And with that metadata, we're going to prompt our large language model, except that it's not going to be a linear thing like here, 1, 2, 3, 3. So it's going to be a more iterative one. But the process is pretty much the same. So we ask the LLM to produce a model. And then in that episode, we took the model and we did the data ingestion. In this case, we're going to focus on this initial step of creating a model, because that will be not a one hop or one step, but more of an interactive, iterative, if you want, interactive as well, because we're going to see that this opens the door to introduce a human in the loop. So we can think of entirely automating it, like getting an LLM to talk to itself, like, hey, LLM, produce a model. Hey, LLM, criticize the model that you have produced and suggest improvements. And then it will regenerate and it can have a conversation with itself until you come up with a condition for it to terminate. Or you can, instead of having the LLM, commenting or providing feedback on the model, you can introduce a human there, or you can combine the two and say, give me your feedback. I'll mark the ones that I approve and the ones that I want to ignore, and I introduce my own. So by creating this type of more rich and more sophisticated applications, we're building something that's closer to the reality of how we work. So yeah, so that's the plan. So I hope that gives enough context. And now we're going to hopefully see it in action.
Very cool. And, sounds like a very interesting topic. I'm looking forward to it. If you have any questions, any comments, anything while we do it, then please don't be shy. Use chat. We can see your messages, so we would try to answer them as we go through.
So it's all going to be in a notebook that we will share at the end of the session. So we'll start with some imports, the usual.
I think we need to zoom in a little bit into this one.
Oh, okay, let me make that a bit bigger.
Yeah,
something like that.
Better. Yes, perfect. Thank you.
Good stuff. Okay, and then the usual, the imports, and then I'm going to be working with OpenAI. So I'm going to use my key, which is already stored in my Colab environment, but you'll use your own. And of course, here in this particular exercise, I'm not using any specific integration with OpenAI. I mean, you could use any, and I have run some basic experiments with open source LLMs running locally through Olama, and maybe that's something that we can explore in another session. But in this version today, we're going to be using OpenAI. So right, so we said that LangGraph is a way of is a library for building they call it stateful and multi-actor applications with LLMs. So I use this analogy and this terminology to call the different parts actors. And in our exercise, we're going to have 3 actors. We could simplify it to 2, but we're going to have 3 of them. The first one is a modeling expert. And that's where I've kind of imported some of what we did in episode 25. So this modeling expert is a system that's capable. I mean, you can see the configuration here that I provide. It's an expert in creating entity relationship models. I mean, which is equivalent to a graph model in our example, and I've given it some kind of basic principles, right? So I said, don't over normalize. I mean, we are going to be starting from a totally denormalized flat table that we get from Kaggle. Don't overdo it, because sometimes in some of the experiments you might go too granular and break it all down in small entities. So don't over normalize, and some general guidance. So like, don't use the same relationship name for multiple relationships. Don't make sure that all the features in the dataset are used. Don't ignore any one of them, and also have one-to-one mapping. I don't want to have kind of complex ETL process where you combine 2 fields or transform them. So let's keep it simple. So it's pretty much general guidance. It's nothing super sophisticated. So we create this first actor, which is the modeling expert, which is simply we're going to be prompting the GPT-4, which is the one that we're using, and all it does is we're going to get a prompt that I'm going to show in a minute, and we use these LLMs. So that's the first actor. And in order to prompt it, because we're going to be using data coming from Kaggle, I've created this utility function that will, given a dataset name, it's going to go and retrieve the metadata. That's the endpoint that I mentioned before, that it exposes. It's called croissant format. I think we talked about it. So if you're interested, you can go to episode 25, and it's in JSON LD format. So all we do is, okay, you pass me your dataset name, and I'm going to go to this URL, which is the metadata description, and basically I'll put it in a textual format. I'll put all the field names in a string. So that's my function. That's what it does, and the prompt again is the one that we used in episode 25. So I'm giving you a list of features. I don't expect you to read the whole thing, but I'm giving you a list of features, which is the columns in the data set, and with that you need to create an entity relationship model, a graph model, and things like attributes don't need to be named exactly after the others, but the usual thing, right? So you can rename it. And I added something interesting that for some of our followers can be of interest, because I said, okay, in addition to that, to generating this model, and I asked it to serialize it as JSON, find what's the schema.org term, the closest one that you can find for each of the elements in the model, and we'll see what it comes up with. But it's a way of providing an annotated data set, and if they will want to publish it, using schema.org, that can be useful. And I tell it what the shape of the output is, and basically it's a JSON document that contains a listing of the entities with the attributes, etc., and then the relationship. And I say, well, don't give me any text or comments, just the JSON. So pretty straightforward. And then all I'm passing is the data set as we retrieve it from Kaggle. So I'm calling the function that I just showed a minute ago, and we put it all together, and that creates a very nice prompt that we're going to be passing to the expert that we've just created. So let's give it a try. So this is what we did last week. This is the first part, the model creation. And I have a couple of data sets. So there's one for supply chain data analysis, which let's find it. So probably Kaggle. Let's see if it finds it. Whoops. What have I done? Yeah, I didn't type it correctly. Anyway, I can use that, which should be on my history. There we go. So that's that. So if you search for it, I think I went to the trending ones, to the most popular ones, and grabbed one or two from there. What I looked at is something that's rich enough. And if you look at this one, it has a file which has 53 columns. So it's rich enough. So it contains potentially a number of entities. So I think that would be a good example. So this is the one that I'll be using. For now, I'm not importing the data, just the metadata, just the description of the columns that I get from these. This is what I was mentioning, the metadata as croissant format. So that's what I'm doing. And I pass the name of the data set, and it will go use my function, retrieve the metadata, generate the prompt using the function that we've just seen. And we're going to call our model generate actor. So I call it model generate, that you have it here, remember? So that's what I call our expert capable of generating models. So here we go. So I'm going to call this. And if I run this, it might take a few seconds, because what it's doing is first going to, interesting, I have something unexpected. So we're retrieving the metadata from Kaggle. We are generating the prompt saying, hey, with this data set, or this structured data set, generate a graph model, taking into account the guidelines that we described both in the prompt and in the configuration. So it's done it. And if I've stored it in, we call it model as text. If I print it, that's the sort of structure that we saw also in episode 25. But remember what it was like, right? So we have a collection of entities. So we've come up with a notion of a customer, and then a collection of attributes. What's interesting and what's new is that we are adding also the schema.org term, which is a pretty, we're not going to use it today, but it's something that we can use in future episodes to kind of create APIs, because we have a model that's already mapped to schema.org terms. So we have a model that it's come up with. Now, one thing that I did, because at the moment this is just code and it's not very visual, but remember that this was the data set. So we have things like in our data set, we can look at the columns here. We have days of shipping, delivery status, category. It looks like there's customer information, product information, city, location. There's plenty of stuff in there. So there's a number of entities, and that's exactly what this has uncovered. Now, if I close this textual view, I'm going to try to show it visually. And for that, I'm going to use GraphViz, which is this old applications that you can use to create simple graph representations. And there we go. So that's the model that it came up with. It's a bit large, but we'll try to make it fit. But it said, okay, it looks like there are several entities there. The first one is a customer, the notion of a customer, and it's annotating it with the schema.org element. But basically, I see that there's a customer, and the attributes of the customer would be the city, the country, the email, the first name, last name. So it's taken a subset of the entities, of the columns in the data set, and said there's a notion of a customer. So there's a kind of a node type in Neo, and customers are connected through the makes order relationship to another entity, which is an order, the notion of an order. Perfect. That makes a lot of sense. An order has a city, a country, an order date, a state, status, blah, blah, blah. And then the order contains products. So pretty cool. I think that's a decent model. It's a basic one, but it's good enough. And like this, we have an idea of what the model has come up with. Perfect. So we have our first kind of actor in our application, and we're going to create a second one, which is the model reviewer, and it's pretty similar in terms of structure. Is identical. It's the same LLM. It's the same OpenAI, except that now we're saying, hey, you are a data modeling expert that can analyze an entity relationship model, a graph model, and suggest changes. So you're not supposed to generate a new model, just provide suggestions. So I really want you to be the critic of the model that we've created, and look at things, for example, like other elements that are under normalized or over normalized. Like, am I still creating like fat nodes, or that I should be, refactoring and extracting entities from? So this is the kind of things that I'm asking, I'm expecting from this critic, from this reviewer to receive. Maybe renaming things that might not be great. So, well, this is the definition of this second actor, which is the reviewer. And exactly like we did before, we're going to have a function that creates the prompt, and it's very similar to much more simple. So in this case, we provide you the model that we've just created in the JSON format serialization, and we said analyze this model and provide 2 or 3 changes. I mean, don't come up with a list of 25. Let's go small, and as usual, no preamble, no comments. Just give me your recommendations. So that's what I've created, and now we're going to test it like we did before. So we're going to invoke the model reflect, as we call it, like what the reflection actually takes place, and we're going to store the output in a variable that we call critique. So that's the feedback that we get from the expert, from our first model, and it's done, and I can print it out, and it's saying, hey, why don't you extract the address as a new entity from both the customer and the order entities? And that makes kind of a lot of sense, right?
So it's a good idea.
Yeah, exactly. Because you see, hey, the customer, it has the city, the country, the state, the street. So maybe that could be in a separate entity, in a separate node. It makes a lot of sense. And the same thing happens I believe in the order. The order has some geographical information. So very valid feedback, right? So that's good stuff. Then the attribute segment in customer might be confusing. Why don't you rename it to customer category? Well, great. I mean, it looks like very, very interesting stuff. It's the same LLM, but it's looking at it from a different angle. So really, really valuable feedback. And there's some others. The relationship contains product could be renamed like this. Fantastic. So we have a second actor that's an expert in analyzing what the first actor produces. And then we have a third one, which is the one that I was saying could be combined with the first one, which is the executor, the one that will take the feedback and apply it to the model. So I call it the model changer or the model editor. And basically, you're a data modeling expert that can modify an entity relationship model that's serialized as JSON, and you apply to it the changes that you're given. And you see where this is going, right? So this is going to be the expert that's going to take the feedback and the first model, and he's going to modify it to create a new iteration. So similar structure. So it's a simple invocation of ChatGPT, GPT-4 in this case. And we have a prompt that's applied the following changes to the model. And I'm going to give a list of changes pretty much in the same way as the critic or the reviewer has produced them. So I'm going to test it here. So that's the prompt. I forgot to put the comment here, but this is let's test it. So test it. And what this is going to do is, like we did before, it's going to call the model change agent or actor, as we call it here, and it's going to pass the message, which is the initial model and the feedback provided by the second actor. So if we run this and we store the output as a new model, it will produce a new version of the model that we had initially, but with hopefully the changes applied as recommended by the reviewer. So we could, once it's done, we can print it as text, which is not going to be very, very helpful. I mean, it is, because we see that it hopefully follows the same structure, but it will be a JSON document, and then we'll be able to visualize it. And it's taking a bit of longer time, which is not an issue. Again, this is sort of a modeling expert, which is kind of a task that's meant to be like brain 2, sort of, rather than Anyway, let's let it finish, and we're going to see how there you go, it's done. So if we print it out, we have a new version of the model, again in JSON, and if we look at the visual of it, that should look something as we saw before. Nicer, right? So we have the person, but we see that it has factored out of the person the entity. It's connected it through the lives at, which also was part of the feedback. I didn't look in the whole detail, but if you look at the first line, extract any relationship, and it's saying connected to the customer and order with lives at from customer and delivered at. So it's giving me a very rich description of the change. So it does a very, very good job at doing this reflection, which is the whole point of our episode today. So it's implemented that. So it's extracted the customer address, and now we have a new type of node. It's done the same with the order. The order is delivered at an address, makes the order stays the same, and this, I suppose, stays unchanged. I mean, I think there was a couple of properties or attributes renamed, but that's pretty much it. So it's done a good job, right? So we've basically shown the whole process. So what we're going to do, so we have now the building blocks. Now we're going to go and get LangGraph to orchestrate the whole thing, and that's what we're going to do in this final step. So I'm going to define the nodes in our graph. I was going to draw a diagram, but I didn't get to do it in the end. So, but we have clearly a node per actor, right? So we have this node, the model generation node is the start node, is the one that will take the input, which Kaggle dataset that we want to work on, and it will generate a first model. So we call it model generating. It's run only once in the first iteration. The second one is the model reflection. And again, I'm calling the functions that we've just seen and the actors that we've just seen. I'm just replicated. Once you get access to the code, you'll see that it's exactly the same functions that we used in the test. We're just putting it into these functions that define the nodes. So the reflection node, it will take the model that has been generated by the model generation node. It will analyze it, and it will produce some feedback. Right? And I have two versions of this because I don't know if we'll have time to look at it. But my first version is I call it human in the loop false. So by default, we go with a fully automated version, which is I get a model generated. I get the LLM to review it and act as the actor that provides the feedback. And then I modify, and then I ask the LLM. But at some point, I might say, hey, I don't want the LLM to do that job. I want a human to enter some input. And as a very rudimentary form of doing that, I said, well, let's call that human in the loop. And if we go human in the loop, set it to true, instead of going and calling the reviewer actor, it will just ask me to enter some input via text. So I would do something like, as an expert, go and refactor these or that. So I will enter by. So just to show how this same infrastructure could be used to combine the two approaches. So. Cool. So this is the second node, the reflection node, where we analyze what we produce. And then the third node is the one where we apply the changes. And so that's the third one, where we basically pass the original model, the changes, and it will produce a new version of the model. So how do we build a graph? So it's a very simple definition, and this is the LangGraph API. So we create a message graph, and we said, well, add a node, which is the first one, the model generation node that we've created here, and we give them names, the model reflection and the model change. And the starting point is the model generate. So my graph starts at the model generate. So that's my entry point. And then I have to define the edges. So before I show this function, the edges is, okay, from the model generation, you go to the model reflection. So that's my flow in the application. So generate and then reflect. Then based on the reflection, you either iterate and generate a new version or you terminate. And it might sound a bit counterintuitive, but my initial thinking was more the human in the loop version. And I wanted to take control and say, okay, if I provide no feedback or an empty string feedback, it means I'm happy with the model and the process terminates. So that's why I put the conditional in that direction after the reflection. Now it might sound a bit, but this, as you can see, it's very simple. We can tune that and change that depending on how we want to do it. But basically, we'll take the feedback. We will decide if we want to run another iteration or if we want to end. And once we apply a change, we go and reflect again. So that's systematic. Every time we have a new version, reflect on it, and then decide if I want to iterate or not. It could have, and then the condition on whether I should iterate or I should terminate is this function that I'm defining here. So I'm saying if I'm in a human in the loop mode, if I enter an empty string, so if the feedback that I'm providing, the length of feedback is greater than 0, so it's not a non-empty string, then you go to model change. But if not, you terminate. Now, if we are in a fully automated mode, which is the one that we're testing now, at the moment, I'm setting the limit after a number of iterations. So I say when the state is smaller than 6, you keep iterating, but then when you get to 6, stop it, right?
Okay. Yeah.
Of course, this could be a lot more sophisticated, and maybe we could go in future episodes on how to evaluate the quality of the model when we decide, rather than saying, after 3 iterations, you're done.
Mm-hmm. Yeah.
What are the characteristics of the model that says it's good enough, stop iterating? So that would be, again, you see that this is a very simple function to show here, but you could build in some logic there that would determine.
I mean, this is just for demo purposes, I say, and if you just prove a point almost, but if anybody wants to take this on, obviously the code will be available in the repo afterwards, and then you can iterate on it and make it a little bit more sophisticated.
Exactly, because it's an additional step in the reflection. So you can say, hey, before you, well, maybe as output of the reflection, you can either we could even add to the prompt, if you're happy with the model, if the model is good enough, return an empty string, and if that returns an empty string, then this logic would work. I mean, but you can tune that to determine when the model is finalized and we want to end. So there you go. So we built the graph. Now we compile it. So if I run this code, it creates the application in the form of a graph, and now we just need to test it. So all that we're going to do is we create an initial prompt. And it's not even a prompt. It's just we pass the data set, and the prompt was created by this function that we showed before. And we're going to use this the supply chain data set that we were looking at. So I'm going with the completely automated process. So I'm setting it by default to no human in the loop. So it's going to iterate up until the state is. I mean, I didn't mention it, but this graph is stateful, and it shares a chain of messages that are exchanged between the different steps. And basically, when that state gets to length 6, it stops iterating. Okay. So that's what it's doing. Mm-hmm. So let's run it and let's see what happens. Because basically, what this is going to do is kick off the process. So go get that data set and start the process. Generate a model, reflect on it, and suggest changes, apply the changes, and then go back again to reflection, and eventually, enter a cycle and get to termination, which in this case would be after I believe 3 iterations. So that might take a few seconds. But I hope the idea is clear, and what's going to be interesting is to analyze what where the process took us.
Yeah,
this is a completely delegated version of it, where and what's interesting about this is that you can introduce the LangGraph. API, the library is really powerful, because it can we're starting to get results. So you can set checkpoints and travel back in time. So for example, if at some point in this iteration things go wrong, you can always travel back to that point and then iterate from there. Very interesting thing, because we are in a. So there you go. So it's starting to this it's calling asynchronously, passing an initial message, which is the data set. And what it's doing is, as events come out of this asynchronous invocation, we're just printing them. And the first one, it's generating the model. The model is in the JSON form that we saw before. And then we are getting some feedback. The customer, it's probably similar to what we saw before when we tested.
Yeah, I just wanted to say, sounds like the same suggestions.
Exactly. So it will go in that process a number of times. A couple of times, and it will terminate there. So
and we're using the same models, right, as before. So again, like every reflection is like 2 to 3 suggestions there, and then incorporating those and then starting again.
Exactly. So there you go. So now it's regenerated the second version of the model after applying these changes. Now it's probably going to provide new suggestions, new, there you go. So under normalized attributes, so in the customer, so it's saying customer F name, map to 2 features, can be extracted to separate attributes. Well, it's, there's kind of a risk element here, because we don't know what this is going to come up with. But yeah, I mean, once it terminates, what we're going to do is we're going to try to analyze the results produced, and again, LangGraph has a number of elements in the library that helps analyzing what's being produced and printing it in a nice way. I mean, another thing that we're not exploring today is the use of Langsmith, which is a kind of an observability element that also the LangChain team offers, and that gives you a lot of visibility on each individual step, and might be another interesting one to explore in another session. There you go. So we have a new version of the model.
Change. Yeah.
And with the new version of the model, probably, there you go. So it's got
here we go. Yeah.
It produces a third set of suggestions, but because it got to size 1, 2, 3, 4, 5, 6, it decided to terminate. So, and then the last node in the graph, the termination node, it contains all the information. So we can say, okay, if we print the output, we see all the different steps, like initial prompt, first version of the model, feedback, second version of the model, feedback, third version of the model, and feedback. And then we decided to ignore the last step because of the way we defined the termination conditions. But we can look at what the model looked like, and we can, for example, look at the first, and it's pretty similar to what we saw before, right? So we see the person, the order, and the product. We see that once that was done in the second iteration, it probably factored slightly different, right? So in this case, wow, look at this. So we had the product. Actually, I print out the feedback that we got, and we can see how it implemented it. Mm-hmm. So we see a new version of it. It's slightly different to the one we saw before, and there's even a third one where we got this feedback, and then it came up with a final version of the model. So it looks like it ended up with an order containing products, the customer, the address. So it's not miles away, but it looks like it converged into a version of it that it was considering good enough. Well, in this case, after 3 steps, that was it. So that's the idea. I mean, what's super powerful about this is that we can, I'm gonna, I suppose, pause here, but before pausing it, I'm going to just take another example, and this one is some crime data. I don't know why I came up with that one. I think it was a rich data set rather than something that I'm particularly interested in. But anyway, we have another 28-column data set with obviously information about crime data. And so if I'm going to run that, because it's exactly the same logic, but just applied to a different data set. And we're going to see how it behaves on a second model, and it should be pretty straightforward, pretty similar. But it's I think this is a simple but really powerful implementation of this idea of reflection, where like I said, we generate in multiple steps and getting feedback from the LLM until we converge into a model. I didn't show the human in the loop version, but if we have time after this, we can show how it goes. So I'll pause here because I'm conscious of time, and with the minutes that we lost in the with the problem with the key. Thank you again, because I was not expecting that. But so let's leave that running. We will eventually spit out the results, and we can analyze them. And let's look at, do we have any questions, any comments, or even maybe you, Alex, anything that you want to?
Yeah, I think that's very cool. I'm always amazed how this goes, and how well that kind of stuff works nowadays. So it's really interesting. I think this iterative process is very, very interesting. I think that gives a lot of opportunities and a lot of possibilities to how to work with data. I mean, you can, like we said, automate it a little bit, and then get some already iterated version. Then you put in some comments yourself, and then let it iterate again to fine tune basically your desired outcomes a little bit more. You don't have to do everything manually. It's very good to have this human in the loop sort of option there. I think that gives you a lot of possibilities. Imagine, you're right, you are the person who is developing the application in the end, and you have a data modeling expert sitting in your office, and you can talk to them and say, hey, this is what we initially came up with, and give me some feedback, and then you pipe that back into it, and then you develop it further. It's really good. Gives it's a very powerful combination.
Yeah, to add to what you said, I mean, exactly, because here we're taking kind of a neutral approach, as in, when we create this initial model, we're kind of applying the general practices. In our trainings, modeling trainings, we tend to say, well, normally nodes are nouns, and verbs can be the relationships, and it's a way of analyzing your requirements, your domain. But then it's true that, when you start iterating because that's the way we work when we come up with graph model, we not only bring this initial approach, but we say, this is the way I'm going to be analyzing or querying my graph. So we can provide additional input, a human in the loop version, like, hey, that's great, and you've got to a reasonable version. But what if I'm going to query my graph with this type of workloads? That's the kind of analysis. Would that suggest any kind of optimization or any kind of denormalization, normalization? So yeah, it can really, really replicate the way we work, and ultimately, if you remember, our objective, and this kind of goes even one step further in that direction, is, okay, let's, in the simplest case, I mean, yeah, we have a data set, any data set in Kaggle, and after an iterative process, we have a reasonably good model, and I can move the data into a graph database and start doing my analysis without us, having to type a single line of code or being an expert, and just relying on the expertise, that's built into the LLM. Here we go. So this has finished now. Let's do a quick analysis, and I'll go straight to the model. So if we go to the first version, oh, why is this vibration happening? It's very interesting. Do you see that, or is that just on my screen?
I think it's just on your screen. I don't see if I. Oh yeah, I see it. Yes, yeah.
Very, very strange. It might be my. Anyway, well, now it seems to have calmed down a bit. Anyway, now it comes back. But if you look at the crime data, there was information again about area, so geographical information about the victim, information about the weapon, status, location, etc., etc. So the first model it came up with, and sorry about the vibration, is we have a notion of a crime. There is a weapon, and there's the victim of a crime, and then it's a location. So a very decent starting point. I don't know where vibration comes from, but anyway. So what in the second step, if I run the analysis, the feedback was the attribute status in the crime seems to be over-normalized. It could be merged with status description. The weapon entity could be merged into the crime. So look, in this case, it went in the opposite direction. It said, why don't you denormalize? So the weapon that used to be a separate entity, now it's been brought back into the crime. Well, maybe a good idea, maybe not. Kind of like sort of the previous version more. But anyway, this is I guess a full, and it came back to it denormalized it again, so it renormalized. That's an interesting point, and I'm happy that this happened, because in this simple version, I'm only taking the current version of the model. Now, if we pass the LLM, this is the current version, and these are the previous versions. So don't travel back in time. Don't suggest changes that undo the changes that suggested in the previous iteration. So it can get more sophisticated and build even more of the way we normally reason about it. But just as a simple example, and with 3 iterations, is a pretty cool example that I would definitely encourage people to try and to improve and to test in their environment, because it's I was impressed with how good it was, and
It's very impressive. Yeah, I think
yeah.
it's pretty cool, and we didn't really add much in terms of the graph
True.
features that come to it. So I mean, you put it in a graph, and then you get some additional insights out of it by maybe use similarity, maybe use community detection, maybe add vector search to it, all of it, and that could give you some insights that could then be bounced back to it, and then refine even some more. That's another way.
Totally.
Yeah.
And you know how we like going meta here. So this was kind of my like episode 1 in this, because I want to go deeper in this. So here
Cool.
I'm totally navigating to the LLM on how to modify the model, create the model. But what if I capture in my knowledge graph my preferences in terms of or my knowledge about modeling or what? So in that case, I can start interacting with and control the way the LLM behaves. So that's where I want to go. But yeah, you're right. This initial step, it just shows more the framework, what this kind of reflection type of agent can look like. But yes, we'll bring the graphs into the process as a way to kind of again own the way this process kind of happens.
Yeah. Oh, that's very cool. So this is a great teaser, a great cliffhanger to end on, episode number 27. So you can look forward to the next one then. I think that's going to be very exciting and very, very interesting to see how this develops and how we can learn and add new features across the coming episodes, and until we have like a super AI graph modeling expert in our hands.
I don't know if we mentioned it on 25, but I mean, the way I see this, I mean, we now produce a kind of a JSON model, and I think we did show how it could automate the creation of the cipher to do the input. But why not? For example, in integrations like with Google Cloud, what was the name of the framework? It escapes me now.
Gemini?
No, but the kind of the sort of ETL, well, it's not really ETL, but the 25, it was Dataflow. Dataflow is I actually have a slide, but the idea is, once we have a model, why do we not use it to generate? Let me put that slide up there. How do I show it? Let me. Window. That's not the one I want to share, is it?
I don't see it on my side. Oh, here we go.
But yeah, so Dataflow is it's kind of a sort of a framework or a tool from Google Cloud to move data from BigQuery into to move data basically and apply transformations. So why could we not generate these type of mapping documents that describe how these data, because that's what we're doing here. In BigQuery we have basically a big fat table that can be pretty much the same that we've seen from Kaggle. So we can use this process to generate the configuration and to automate the ingestion from BigQuery into Neo4j. So that's one example. But the moment we kind of have come up with a model, we can automate and not only come up with a model, but map it. Remember that the model that we generate, it maps to the sources, to the original file, to the original columns in the file. So we can basically translate that into a sort of an ETL process to move the data in the same way we did it using just Cypher, but in using the Dataflow framework here. So that was another idea. Too many ideas to
Indeed, too many ideas. All right, but that's cool. That I think should round us up out very well to the end of this episode, and gives us a nice, like I said earlier, like a nice cliffhanger to what to look forward to in episode 28 and onwards.
Yeah.
Next, or do you want to say something?
No, I was going to say, because I was reading a question from Peter on whether the trying it with different models behave in the same way. I've tried only with not the commercial ones, but the open source ones, and the difference was substantial. So it was the quality was much better with OpenAI, but I have not tried it, with Anthropic or any of these, Gemini. But that's definitely something that I want to give a try. So that OpenAI perform way better than, for example, which one? Mistral is the one that I tested through Olama, and Zephyr. I tried a couple of them, and the quality was not as good. So that's my kind of data points that I have, but it's not really an exhaustive or a really serious analysis. My first impressions is that the quality was much better with OpenAI, but yeah, worth exploring with others.
Absolutely. I mean, there are always other options, and if you try it out with something else, let us know. Give us a shout out on the YouTube comments maybe, or in the community forum, and let us know if you had some experiences with trying it out with different models, and what your results are. So before I let you go, next stream is happening on the 18th of April. So little break next week. No session, but afterwards I'm coming back with Tomasz as a guest. He wrote a book on graph algorithms for data science, and we will introduce this book with a little bit of an in-depth look at the chapters, the contents, and what he wrote there. I think Tomasz is a well-known figure in the graph data science GenAI world around Neo4j. He writes very, very many blog articles and has a great knowledge on the topic. So I'm looking forward to having him as a guest to talk about his book in more detail in 2 weeks' time. And between now and then, what's next? What can you do? Join the Neo4j community. Join our Neo4j Discord server. And for learning, you can check out the Graph Academy with courses. My colleague Martin, or our colleague Martin, just released something on vector search. So if that's interesting to you, then you can learn there. And obviously, there is a wide range of sessions around GenAI as well these days, but also beginners courses for Neo4j newbies. So yeah. With that, I think we are at the end of today's episode. Looking forward to next month's edition. Wishing you all a great rest of your day, rest of your week, and hope to see you soon in one of these streams or at the community sites. Let us know, reach out, and speak later. Take care, everybody, and thank you, Jesus, for the great demo today. It was really interesting. Yeah, thank you.
See you next time.
See you next time.